So now to the topic of the hour. John Wallace reached out to me a little over a year ago about the work PFI was doing researching 60-inch wide corn rows and cover crops. And I was really happy to reconnect with John over this summer about that. And I'm glad he's able to be with us today to talk about his work and his team's work at Penn State on this topic. So without further ado, please give a warm remote welcome to John Wallace. Take it away, John.
All right. Thanks, Stefan. Screen here. All right. Does that look
Looks
good?
good. Looks very good.
Thank you. Well, good morning. I first want to just say that I really admire the mission of PFI and the work that you all do. So I'm really happy to be here. I'm going to share what we've learned about interseeding here in Pennsylvania and what we're currently learning and doing from a research standpoint. Because I'm a weed scientist, it's going to tilt a little towards weed management considerations in the back half of my talk. But like Stefan said, I'm really interested in what you guys are learning too. So hopefully I can get through my material and we'll have plenty of time to have a nice discussion. So a really important kind of part of the story of interseeding and its potential and its utility in my region is how the growing region kind of impacts interseeding potential. And so I just wanted to start by describing that a little bit for you. So in Pennsylvania, we're mostly on silt loam soils, and we kind of cross a climatic gradient throughout the state where we have pretty long growing seasons and in the southeastern part of the state up to 200 days, and a much shorter growing season in the Allegheny Plateau and the northern tier. And so that really shapes kind of how we think about cover cropping and interseeding. And so I'll be touching on that and going back to that quite frequently as I talk about what we're doing. And then I have a couple figures here just to illustrate the obvious point that we're not the Corn Belt in Pennsylvania. You know, our agriculture is dominated by our livestock industry, dairies primarily. So we, on our cropland, we have as many forages as we do grain crops. And so you can see in the bottom right-hand corner, another unique feature of Pennsylvania agriculture is that we have many small farms. And so what you're looking at is Lancaster County, where we really have concentrated ag lands, a lot of small dairies. And so a corn, soybean, cash grain rotation, we think is probably on only about 20 to 25% of our acres. And it's embedded in this matrix of kind of longer rotations. And so that shapes a lot of things, and it shapes kind of some of our weed management challenges as well. And so what's the agronomic fit for cover crop interseeding? So here's a nice picture of a typical small farm, dairy farm in Pennsylvania. And so a couple features, you know, that are important. We're farming on a lot of erodible slopes, and we also have manure management issues, nutrient management issues. And so we place a big emphasis on conservation tillage practices. We have a lot of no-till acres, up to 65% of our annual croplands use no-till practices. And as far as cover cropping goes, we're doing pretty well. So the latest survey suggests that 37% of our annual cropland acres in Pennsylvania see a cover crop. But thinking about that, that probably means that all our corn silage acres and small grains where we're not double cropping soybeans are probably seeing a cover crop, but we have a lot of acres in corn grain and in full season soybeans where we're not getting a cover crop on. And so that really is where cover crop interseeding comes in as a way to get cover crops established in those late harvested crops where we have a very narrow growing season after crop harvest. And so a lot of the early work in Pennsylvania, as far as interseeding, was really, that's what motivated the research, is really how do we make that work in corn grain systems. And so, if we think about what the management objective then is for interseeding, again, probably the first priority is those acres that are not getting a cover crop. And so the important thing there is to make sure that we're meeting those soil conservation objectives and preventing soil erosion, and then using those cover crops as a nutrient management tool, scavenge for nitrogen, keep them in the system, prevent them from leaching. But since interseeding has kind of taken off a little bit, there's additional interests in why we might go to interseeding practices. Obviously, this interest in soil health and the importance of adding diversity, both cash crop diversity and cover crop diversity into a rotation. And so by establishing those covers earlier, you have a greater suite of species that you can potentially get out. And so you can add some additional diversity in your rotation that way. And then lastly, we'll talk a little bit about today is this idea that, we're using these cover crops potentially for multiple purposes, where we might be thinking about taking those cover crops for forage or integrating livestock into the rotation and grazing those cover crops. So kind of in order to tell you about what we're doing now, I just want to give you the context of what's been done in the past in our region as far as developing best management practices for interseeding. And so everything I'm going to talk about today, when I'm talking about interseeding, is establishing cover crops earlier in the corn growing season and using a high clearance grain drill to do so. So I realize there's multiple ways to get those covers established in the corn growing season, but all the work I'm going to talk about is drilling those cover crops in. And so you can see the setup that we're working with. This was just the high clearance drill that was developed and modified here at Penn State and is now being sold as Interseeder technologies. We're drilling cover crops in 3 rows between 30-inch corn rows, so on 7.5-inch spacing. We also did some work several years ago on trying to identify what the shade tolerant cover crop species are that really work well in this type of system. And so there's probably 10 or 12 different species that were evaluated for a couple of years. And that work really demonstrated that when it comes to a grass cover crop species, annual ryegrass was kind of the workhorse, most consistent across a wide range of conditions as far as establishment. Out of the legumes, medium red clover, as well as crimson clover, have done pretty well and are pretty consistent establishers and are able to persist under that corn canopy. We've tried other legumes which have been a little more spotty. And then also, I'm not showing here, is forage radish has done quite well in Pennsylvania as well as far as an interseeded cover crop. And so if we're looking at interseeding mixtures, a typical mixture might be annual ryegrass and either crimson clover or red clover with forage radish in order to get some diversity out there. There's also some work that I was involved with looking at identifying kind of the best timing for interseeding in order to establish that cover crop, but also potentially prevent a yield drag. And so a lot of the early concerns about a yield drag were related to establishing that cover crop too early. And so you're really interseeding a weed at that point. And so our research showed that V2 is probably too early to interseed, probably maybe V3. But once you get into that V4 to V6 range, we really didn't see any yield drag. And that's been pretty consistent both in our on-station work and on-farm work. And I will note that this idea of interseeding a weed, it's not just that. You have to realize that, when you're interseeding at V2 or V3, you have no more weed control after that point. So we're still seeing a lot of weed escapes and weed breaks after V2 or V3. And so when you look more closely at this data, what you would find is that, yes, we have more interseeded cover crop there, but we also have greater weed pressure at those earlier interseeding timings. So that brings us to herbicide management. And so again, this is some of the research that I've been involved with in the past years. And so, extension weed scientists will tell you that pre-emergent herbicides make post-emergent herbicides better. And this is definitely the case when we're thinking about coming in just prior to interseeding with post-emergence pass of Roundup or glyphosate in order to clean up the weeds and establish that cover crop. And if you're doing that at V5 or V6 and you're 5, 6, 7 weeks after planting, without any kind of setup residual herbicide program, those weeds are going to be big. They're going to be more challenging to control. And so we spent several years doing field trials looking at what are kind of setup pre-emergent herbicide programs that provide that early season weed control, make that post-emergence application better, but also break or dissipate in the soil in time to allow for the establishment of those cover crops. And so we had identified a few. They work pretty well in our area. That does not mean that they're going to work in Iowa or across the Corn Belt. So this type of work really needs to be done on a regional basis across different soil types and different environmental conditions. But typically what we would advocate for is to use some type of short-lived residual herbicide program and come back with post-emergence pass of glyphosate prior to interseeding. So along with some of that kind of research that happened on station at the land grants here in the Mid-Atlantic, there was a series of on-farm trials. It was part of the NRCS CIG project. And so I'm showing a figure from those on-farm trials, and what you're looking at is fall biomass. The circles are sized according to how much fall biomass we measured in these interseeding trials. And we were using a common mixture of ryegrass and 3 legume species in these trials across a couple different years. And so the reason why we put the figure together like this is that we thought that we might see some regional differences in interseeding performance, climatic or latitudinal gradient. And so we thought that it might jump out if we displayed the data like that. But what you can see is just a lot of variability, right? So you can see the smallest circle there is just 50 pounds of dry matter at harvest compared to half a ton of dry matter biomass at harvest. And so the only thing that we were controlling in these on-farm trials that happened was really the mixture and kind of the relative timing trying to target that V4 to V5 stage. And we missed a lot of valuable kind of data, perhaps by not being there earlier in the crop growing season and understanding maybe what the management limitations or kind of environmental limitations that were kind of influencing the amount of biomass that we were getting. And we are also, you look at this and you wonder, what constitutes success? What are we looking for? Is 200 pounds of dry matter biomass at harvest a successful interseeding? And so we, at that point, had yet to really start to measure the services, the conservation benefits or the ecosystem services from interseeding practices. And so that kind of is the context of what's been happening, happened in kind of the initial phase of research of interseeding in Pennsylvania. But in general, so as this has been put into practice a little bit throughout the state, I don't think the adoption rates are very high, but it's being used in different parts of the state. And so we have many obvious examples of success, and oftentimes those success stories are occurring in kind of the northern tier or the shorter growing season regions in Pennsylvania. So that's really important because those are the regions where it's really hard to establish a cover crop after harvest. So even if we get cereal rye out on those corn grain acres after harvest, we don't get much production prior to winter. And so you can see here in the northern part of Pennsylvania, that's plant hardiness zone 5 for your reference, where we interseeded annual ryegrass. On these erodible slopes, you can see the tremendous benefit that we're getting from kind of soil erosion protection, as well as nitrogen scavenging. We're often pretty successful interseeding annual ryegrass, even in kind of the central part of the state, in zone 6, so a little warmer or longer growing season. So just another picture showing where we, in this particular field, it was an organic field, and so we were plowing down legume cover crops and applying manures. And so you can see and imagine the potential benefit as far as nutrient management and nitrogen scavenging that we're getting out of interseeding a cover crop like annual ryegrass in this system. And so that's just the following spring after interseeding in corn. As a weed scientist, I love to show this picture. So this is actually on the research station, and so what you're looking at is, you know, that in one half of the field, on the previous year, it was in corn, and annual ryegrass was interseeded on the left. No interseeding on the right-hand side, and then really no other management differences as far as fall management post-harvest. The right-hand side was left fallow. And you can see the weed suppression we're getting from that interseeded annual ryegrass crop on our most troublesome and prolific herbicide-resistant weed species, mare's tail. So that's just another example of some of the benefits that we're potentially getting out of interseeding cover crops. But for all those kind of success stories and obvious examples of you know, conservation benefits and ecosystem services, we have a lot of cases that look like this. So this is in kind of the southern part of the state. Again, longer growing season, warmer climate, and higher yield potential. So in the Lancaster region and the southeastern part of the state, where we're in the 200+ bushel yield potential range. And so this is some data and pictures from my colleague Ron Hoover. And so this is pretty typical. We're in this region, we're able to get the cover crop established when we're interseeding. So this is 6 weeks after interseeding. And then you go through the hotter part of the season, and the corn has canopied hard. And now we're kind of getting into leaf drop, and you can see that the cover crop has kind of sloughed off, is really challenged to get back and growing. And so in some years, we'll see that cover crop come through that and start to grow again. In other years, we'll see just complete loss of the established cover crop. And so that remains a big challenge, and we think it's related to both kind of the climatic patterns, the longer and hotter growing seasons, as well as just the competition from the corn. So under 200+ bushel corn, we just have a much more stressful environment for those cover crops to persist. And so as we've seen those types of challenges, we've tried to think through some of the potential corn or cover crop management practices that we might be able to manipulate in those systems in order to not just have that cover crop establish but for it to persist in order to get the most production and the most conservation benefit. And so some of the things that we've been thinking about and have tried in different capacities have been the potential for manipulating corn populations. And so potentially going to flexier hybrids that may allow us to drop the corn population without taking a yield drag, and potentially opening up the canopy just enough to allow those cover crops to persist under the canopy. We've also kind of rethought the interseeding timing. So, you know, we were originally advocating and recommending interseeding around the V5 growth stage. And so the thinking here is that if we interseed earlier and allow a greater time for those cover crops to establish, put a good root system down prior to corn canopy closure, that those cover crops may be able to persist better through the drier and hotter part of the year. And so perhaps that 2 week difference, that extra 2 weeks of good growing conditions for the interseeded cover crop may make a difference in persistence. And so the last thing that we're just now kind of dipping our toe in is looking at manipulating row spacing. And so I'm going to talk a little bit about our first year experience in narrow versus wide row corn. So before I get to that, I just want to talk a little bit about what we've learned from some of those other strategies. So there was an experiment that was conducted several years ago across Penn State, Cornell in New York, and at the Beltsville ARS station in Maryland. And that study tried to manipulate corn population. So it looked at a range of seed drop and using a flexier hybrid, and then looked at kind of crop yield as well as cover crop establishment and production and weed interactions in that study. And so the big take home from that suite of studies was that reducing seed drop by about 10% when you're using these flexier hybrids in this region. And so when we're dropping 10%, our probably standard plant population or seed drop would be about 32 to 33,000 plants or seeds per acre. So we're dropping it down to about 28,000. And if we did that, it didn't influence yield. And we also saw a measurable change in the amount of light that was getting down into the canopy to the soil surface. So the question of whether that small change produced a big change in cover crop performance was complicated by weeds, because what this study also demonstrated was, yes, we can drop the corn populations, we can open up that canopy without taking a yield drag, and that has measurable changes to light transmission into the canopy, and that also, you get a positive response when it comes to cover crop biomass, but you also get a positive response when it comes to weed biomass. So you're opening up that canopy and you're getting more weed pressure, even when you're making that small change in your corn management practices. So again, so the earlier interseeding, we have a little bit of data on that. Again, this is coming from my colleague, Ron Hoover, who did a few on-farm trials in that southeastern part of the state, the longer growing season, warmer, higher corn yield potential. And so he looked at interseeding around the V3 stage versus around the V6 stage. And what that data really demonstrated was, yeah, there's probably a benefit to going earlier in those types of conditions, or getting more biomass production when we're going earlier. And we're also, in some of those more challenging conditions, we're getting greater persistence of the cover crop. And so we were fairly keen on this idea for a while, and but I think the earlier interseeding also presents some challenges, which I'll talk about here in a few slides. Okay, so we were lucky to get some SARE, Northeastern SARE funding in the past year in order to be able to continue some of this interseeding research. And so I'm going to tell you about our first year experience with wide row corn here. And so we had a field experiment out this past year where we had 3 locations. And so that was really important because we were able to do these experiments across that gradient I've been talking about. So in the Lancaster County is the Landisville site you see in the southeastern part of the state, Rock Springs in the middle part of the state, where Penn State is located. And then we were doing this with my colleague Matt Ryan at Cornell as well. And so what we wanted to do was to kind of look at these different types of practices together and in combination. And so we set out to look at variety selection, so comparing a flex year hybrid versus more of a determinate year, as well as interseeding earlier versus late. So our target was V3 versus 6. And then also manipulating the row spacing, so going from 30 to 60-inch rows. And so we had combinations of all those together in the field. All right, so a bit more about how we did that. So again, we're looking at a determinate year in a semi-flex hybrid, and you can see, what my local seedsman described is that these flex years that you're seeing in the picture on the right, the leaf architecture that you're going to get, it's going to be a little lazier, a little more relaxed. So those leaves are stretching out and trying to capture that sunlight. And that kind of allows for those lower plant populations with those flex years. But some of the determinate years, at least for this particular company we were working with, they're going to have much more kind of upright architecture as far as the leaf angle goes. So our seed drop was 32,000 seeds per acre, and we kept the herbicide program very simple because we were manipulating a lot of things in which the herbicide program could have complicated. So we were just starting with a burn down and then applying a post-emergence glyphosate application at the V3 growth stage. Typically we would be recommending that we're going to be splitting our nitrogen applications in these no-till systems, side dressing. And in an interseeding context, if you're interseeding around V5, that lines up about with side dress timing. But because we were going earlier and looking at the V3 growth stage, we were applying all our nitrogen up front rather than splitting the nitrogen applications. So again, we had that on 30-inch rows, and so the same setup on 60-inch rows. And so the seed drop on the 60-inch rows, we maintained at 32,000 seeds per acre. And so we're just concentrating those, instead of 7-inch spacing in row, we're narrowing that in row spacing down to maybe 3 or 4 inches. And so I realized that this is kind of perhaps an inartful method, but we were not set up to do twin rows. And so I've been following that work. And so some of the results I'm going to show as far as yields, keep that in mind that we're maybe not doing that in the best way. Okay, and so the other thing that we did is we're scientists, so we needed to control a lot of factors. And so rather than go with mixtures, where we then had to kind of parse the competition, the interspecific competition going on between cover crops, we wanted to look at monocultures and just measure the difference in biomass production of those monocultures as we changed interseeding timing and the corn management strategies. And so we were looking at annual ryegrass alone, cereal rye alone. And so cereal rye has not been a species that we've recommended. It's less shade tolerant than annual ryegrass, does not seem to persist as well. However, from an agronomic standpoint, there's a lot of benefits to cereal rye in comparison to annual ryegrass. So we were kind of interested to see if some of these different management practices facilitated kind of the use of cereal rye in interseeded systems. So we had annual ryegrass, cereal rye, and medium red clover as our 3 species. So that's a lot of data, and I don't have time to really get into the data. I'm just going to hit the highlights. We're still kind of working through a lot of that. And so I just want to tell you what we've learned in the first year. And so we did learn some pretty dramatic lessons. And so I'll just hit the bullet points. I do have the data here below in the tables that you can see, and the tables are set up so that I'm going to show you kind of certain comparisons here. We're looking at spacing and varieties. And so that's averaged across cover crops and averaged across interseeding timings. And I'm going to keep showing the data by location, so you can see that kind of difference in the climatic gradient. So moving north to south from Cornell down to Lancaster in Pennsylvania. So the big take homes is we saw the climatic gradient. You know, we got greater cover crop biomass production across all those different types of treatments at our New York location. And then we did pretty well or okay at the Rock Springs location. And then we were really challenged and did not get very much cover crop biomass production at that southern location. As far as the 30 versus 60 split, we saw about a 2-fold increase in biomass production when we went from 30 to 60s. And I realized that does not probably seem very dramatic. I've seen a lot of data, including some, I think, from Practical Farmers of Iowa, where the benefit is more like a 8 or 10-fold increase in biomass production. And I think that that's probably related to the fact that we're looking at monocultures, and 2, we're concentrating on these cool season cover crops. And so if we were looking at warmer season cover crops, I would imagine that we would see a bigger difference. And then one of the interesting things that I'm really interested in following up on, and seem to be pretty consistent in our results, is that we did see this benefit of a determinate ear compared to a flex ear in the narrow row corn. So we saw greater biomass production from the cover crops in that determinate ear variety. And so that suggests that we're getting more sunlight into that canopy and using that determinate ear. And we did measure that. I don't have the data to show, and so hopefully we will have that data soon to see how much more light transmittance we're getting into that corn canopy by just changing corn varieties and different architectures or leaf architectures. So we're really excited about that, but we have a lot of this data where we're measuring light penetration into the canopy on about 2-week intervals from about V6 through silking. Okay, so as far as interseeding timing, what we saw was really pretty consistently, we saw a greater benefit of interseeding early at the V3 stage in comparison to the V6 growth stage. And so that's what we expected. We thought that there might be some differences in the cover crop species, that perhaps interseeding later would not matter as much for something like annual ryegrass in comparison to cereal rye. But that effect of the early interseeding outperforming the late interseeding was pretty consistent across the different cover crop species that we looked at. As far as corn yields, so, perhaps not surprisingly, we saw a yield decline or a yield drag in the 60-inch rows. And you can see those percentages that you're seeing in the table gives you the range of the 30-60 comparison for each one of those varieties. So somewhere in the neighborhood between 16 and up to 45% decrease. And again, I am keep in mind that there's probably improvements as far as our setup for trying these 60-inch wide row corns. If we went to twins, that may make a difference. But we also saw some interesting results in kind of the varieties. So we saw greater yields in the determinate compared to the flex in the narrow row corn, and we saw greater yields in the flex ears compared to the determinants in the wide row corn. So again, it looks like this idea of leaf architecture is potentially important, and it matters what row spacing you're on. Okay, so the last thing is part of the story, and probably part of the yield drag story too, is the amount of weed pressure that we saw. And so, we saw really significantly higher weed pressure in the wide row corn compared to the narrow row corn. And that was really the case at a couple different locations. So, in New York and Landisville, where you're seeing over a half a ton of dry matter biomass of weeds, that's causing a yield drag. So, typically in weed science, we think if we're under 200 pounds of dry matter biomass of weeds, that we're probably not taking a yield drag. So I just wanted to close that part by offering a couple just observations and lessons I learned from a weed scientist perspective about wide row corn in our first year. And so the first thing I wanted to note is that, if cover crops are going to be livestock feed in these wide row systems, the herbicide options are really limited. They're pretty much limited to a glyphosate application. And so that's really important to note. I'm not sure that everybody knows that. And so as soon as that livestock or that cover crop ceases to exist as a green manure that you're going to burn down and you're feeding it to livestock, it's subject to these rotation intervals. And if the cover crop's not on the rotation interval table in a herbicide label, then you're restricted to the longest rotation interval. And so if you're doing these highly diverse mixtures, you're likely interseeding cover crops where there's no guidance in the rotation intervals on the herbicide labels. And so you're going to be really restricted in what you can use. The second point I wanted to mention is, it was pretty obvious to me that when we're interseeding cool season cover crops and we have summer annual weeds emerging, late season escapes emerging with those cool season covers, that weeds are going to win in that environment. They're just genetically different. They have higher relative growth rates in comparison to those cooler season cover crops, and they're going to pretty consistently win in a lot of different environments. And so I think if we want to think about using the cover crops as a weed suppression tool as well in those environments, that we need to have warm season covers in the mixture. And if we're going to get the soil conservation benefits in addition to the potential forage or livestock grazing benefits, that we need to be thinking about how can we design mixtures where we're including warm season covers and cool season covers in order to maintain weed suppression and get the benefits that we want. Okay, so again, I want to talk a little bit about herbicide resistance management and interseeding. And so this is something I've been thinking about. We're dealing with, several herbicide resistant weeds in our state. Mare's tail is our biggest problem. We do have palmer and water hemp. Water hemp is not as widely distributed in Pennsylvania as it is in the Corn Belt. And so I just want to tick off a couple notes about that. So one, if we're thinking about the types of herbicide programs we might use when we're interseeding. So the simplest, a burn down and a post-emergence application of glyphosate prior to interseeding. And I guess if you're able to do that in your system and get good weed suppression, keep doing whatever you're doing because it's obviously working. I also see a lot of, folks using half rate residuals followed by a post-emergence application of glyphosate. From a resistance standpoint, that's a bad strategy. So we want to avoid applying low doses of herbicides, because what happens is when we repeatedly expose low doses of herbicides to these weeds, they can quickly evolve resistance. And so that's called creeping resistance. And so a better approach than cutting your herbicide rate is to use a full rate of a herbicide that persists for a shorter amount of time. And so we think about those kind of short-lived residuals as setup programs. And so a better resistance management approach is to use a full rate setup program and come back with a glyphosate program prior to interseeding. Again, from that's typically what we're recommending, and in those areas that are not challenged by some of those resistant weeds, it works well. If you are challenged, then you have to think about additional kind of strategies as far as herbicide management in these types of systems. And so adding additional modes of action in the posts has some potential. We've looked at that a little bit. Some of those products that we might use post-emergence are going to have some residual activity that can injure cover crops. The obvious addition that you might be able to add is if you have the Liberty Link trait in corn, you could include that and still come back and interseed pretty safely. And so the other thing is there's this potential, I think, to potentially use overlapping residuals, and I want to describe what that might look like. And so I had a field experiment out this past year, and so I'm trying to kind of work through this concept of overlapping residuals. And so what this experiment was really trying to get at is to go back to the drawing board, and rather than interseeding at V5, if we're interseeding early, what does that mean as far as being able to use residual herbicides? I wanted to look at different species tolerance to these types of programs, and then I wanted to test this idea of using overlapping residuals. And so the treatments were, a very simple kind of control where we were just coming in with glyphosate prior to interseeding, or a full rate setup program. So we're using Verdict, which includes Outlook and Sharpen, and coming back just post-emergence with glyphosate prior to interseeding. And I compared that to approaches where we were using a residual at planting, and then we're coming back and interseeding at V3. And after the cover crop was established, we would come back with our second pass. So it's still a 2-pass program with another residual herbicide. And so the reason why we can do that is there's a suite of herbicides, group 15 herbicides, that only control emerging seedlings. And so, the herbicide has no, or shouldn't have any activity on emerged established plants. And it's that class of chemistry that we're using to control things like water hemp and palmer and corn in this type of approach. So the take home for that, so what I found was when we went earlier at V3, even some of these short-lived programs were injuring ryegrass. And so, V3 may even challenge using kind of just short-lived setup programs. However, cereal rye is coming through some kind of longer-lived residual herbicides in comparison to ryegrass, and I'll talk about why that is. And then the other thing we found is that we were able to come back with these residuals, this residual after we interseeded, and it really didn't have a significant impact on those established cover crops, and it provided greater weed control as well. So I'm going to continue to test this strategy, because I think for regions and areas in Pennsylvania that may start to deal with things like water hemp more frequently, we're going to have some of those strategies available to us for us to really get good weed control and interseed. So I want to talk a little bit more about that. So when we're thinking about these different herbicide programs and the potential injury to cover crops, there's two factors. One is, how long does a herbicide persist in the soil? And so we did some work on this, and what we found was that we see differences in some of the herbicides that we use for annual grass control and control of small seeded broadleafs, so the group 15 herbicides. And so we were able to identify the shorter lived group 15 herbicides, things like Outlook or Harness, and use those in programs prior to interseeding. The other thing that you find frequently in corn herbicide programs is then a combination of the HPPD herbicide and atrazine. And so we also came up with some guidelines about that as far as what to avoid and what not to avoid. And again, this is specific to region. Some of this, the fact that we can get away with using some of these products in Pennsylvania does not mean that other areas will be able to do so. But the other part that's been, to me, unexplored and offers some potential here is that it's not just about persistence of the herbicide in the soil, it's also about how cover crops differ in their tolerance to any given dose of a herbicide. And so what you see here is, and we're able to do this, we're able to simulate the degradation of herbicides in the soil using greenhouse approaches. And so we're able to then screen a lot of different cover crops. And so what you see is crimson clover planted into soil that we applied different rates of Callisto in this case. And so you can see that even at 3 half-lives, when you're down to a very low dose of the herbicide in the soil, we're still getting control or injury of crimson clover. But if we move to a different species, say Austrian winter pea, we might see greater tolerance of Austrian winter pea to higher doses. And so this is the type of work that I've been doing, because I think if we're going to come up with diverse mixtures and really get the most benefit from a soil health standpoint and using these practices, we need to identify some suites of cover crops that are tolerant to specific herbicides. And so where we might find the variation in tolerance is taxonomic. So grasses are going to differ in their sensitivity to herbicides relative to legumes and radish and brassicas. And then the other thing we know based on how these herbicides impact weeds is that seed size matters. And so there may be a difference in cover crop seed size that we can exploit. So, combining cover crops with larger seeded, mixtures that are only larger seeded cover crops may provide us more opportunities to use better herbicides in these types of systems. So just an example of that. So here is some data from that type of research. And so I just want to illustrate that type of this point, in that on the x-axis is what's called the ED50 value. So that's the herbicide dose in which we see a 50% decrease in biomass of the cover crop. And so if you're out close to 1, that means that the cover crop is very tolerant to that herbicide. If those bars are close to 0, that means that the cover crop is very sensitive to that herbicide, even at low doses. And so here we have 2 long-lived residual herbicides that we use in corn, dual or residual, so metolachlor or pyroxasulfone. And you can see there's differences in cover crop tolerance. So with dual, we might be able to use brassicas as an interseeded cover crop, whereas brassicas are very sensitive to pyroxasulfone at very low doses. So we would want to avoid those types of species if we're using a herbicide program that has Zidua in it. The other thing that jumps out here is the differences in grasses. So, we can get away with perhaps interseeding cereal rye when we're using Zidua, but perhaps not with dual. So that's one of the things that I've been working on. I've been working through different classes of chemistries and screening about 12 to 14 different cover crop species. And what I'm hoping that type of work can do is to help, if you're locked into a specific herbicide program because of your weed pressure, you may still be able to identify cover crops that have a greater potential to establish in those systems despite the use of those residual herbicides. So that hopefully will be forthcoming soon. And then lastly, I just wanted to make a couple additional kind of observations about interseeding and weed control tactics. And so along this point, really the best way, the sustainable weed management, kind of the pillar of sustainable weed management is diversity. And so the more diversity we can get in our crop rotation, and that includes how we integrate cover crops into those rotations, those types of practices are all going to drive down weed seed banks. And so that's going to offer even more opportunities for how to introduce cover crops into those rotations. But I just want to point out that interseeding is perhaps a barrier to doing that, because I really think that we need to be able to control weeds and to drive down weed seed banks, particularly when we're dealing with these herbicide resistant species. And so we really need to make sure we're controlling weeds prior to interseeding. And that remains challenging as far as herbicide management. Again, just noting these integrated livestock systems I think are really exciting, but they're going to need to be low herbicide input systems because of these restrictions. I think we also need to think about, the need to reduce seed rain, in particular for water hemp management in the corn phase, because it's much more challenging to control in the soybean phase. And so we just need to be using good herbicide management practices to do that. And so with that, that's all I had. I have a whole list of people who have worked on interseeding both at Penn State and across the region, past and present, on here, and I've showed a lot of their data. So really appreciative for all those folks. And Stefan, I'll turn it back to you.
Great, thanks, John. That was a lot of excellent info. Addressed a lot of questions that have come up over the years. We've got a few minutes for questions that came in during the talk, so I'll get right to it. John Bakehouse is asking, he's thinking about retrofitting a side dress toolbar that he uses to apply UAN fertilizer to seed cover crop while he's side dressing UAN fertilizer. He's wondering, are there any potential problems or interactions of a UAN fertilizer interfering with the establishment of a seed mix when you're doing that at the same time? And he's thinking 60 to 80 units of nitrogen that he's applying as UAN.
Yeah, that's a good question, and I've heard other people raise it, and I don't know that I have a good answer. I've heard some folks suggest that there's, if it's coming up right, in that band, if cover crops are coming up in that band where you have that concentrated UAN, that there's potential for some burn. But I really don't. I really don't know, and it hasn't really been evaluated as far as I know in our region or elsewhere.
Okay, I'll move on to Warren had a question. If you've done any comparisons between drilling versus flying on the seed, or maybe just broadcasting it.
Yeah, so that's a great question. So we haven't looked at kind of the comparison between drill interseeding and the later establishment flying it on. The early work at Penn State, prior to going to a modified grain drill, they were kind of blowing it on and then having an implement where it kind of raked it in, so to speak, and saw fairly inconsistent establishment rates using that type of practice, and that's kind of why they moved to a high clearance grain drill approach. We've also done several years. I was involved in on-farm trials in organic grain crop systems where we compared broadcasting just prior to or just after last cultivation to drill interseeding. And in that scenario, again, so these are tilled soils that have been worked pretty friable after you come through with the cultivator. And so we saw in 1 year we did it at 3 locations, and we really had timely rains that year. So we saw kind of minimal benefit of drilling compared to broadcasting. And the next year it was much drier, and we saw a benefit in drilling compared to broadcasting. The other thing that we found that was interesting in that work was that we were looking at mixtures in that case, and we saw a definite difference in the composition of the mixture depending on the establishment method. So where we were interseeding the larger species like the forage radish were much more dominant, and where we were broadcasting the smaller species kind of were represented a greater proportion of the cover crop mix.
Great, cool. Thanks, John. Question, you talked about light penetration through the canopy earlier, and so there's a question about Bayer's short stature corn, which is something like, I guess, 3 feet shorter than average. So would you hypothesize better light infiltration, that possibly benefiting both cover crops, but maybe also weeds? I don't know.
Yeah, I'm trying to get my hands on some of that, because I've learned about that, and I immediately thought about those potential benefits of that shorter corn. I don't know. You know, I'd be interested to see what the leaf architecture looks like on that shorter corn, and so I think it's definitely something that we need to try, and I'm interested in trying in the next year or two.
Okay, and there was a question back to the previous question about broadcasting. Did you do any incorporation of that broadcast seeding, or did you just leave it on the soil surface?
Well, in that case, we were not incorporating. We were doing it after. We were doing it after cultivation, right after cultivation, the day of cultivation, and really the way to perhaps do that is to combine that pass, and that you might be just blowing on or broadcasting that cover crop right ahead of cultivation, and so the cultivation acts as the incorporation tool. But that depends also on what the setup is. If you're working that ground shallow versus, you know, if you're trying to throw a lot of soil with that cultivation pass, you might end up burying some of that seed too deep. But yeah, so we didn't in that case, but I think that would improve things in tilled ground for sure.
Cool. So we've got about 1 minute. So I got one last question here. It's from Fred, and maybe he can, I hope I'm going to get this right. He's referencing some earlier pictures that you showed in the spring of cover crops that looked like only grasses were planted. But did you use any legumes as well? Maybe Fred, you can clarify in the chat box. I think maybe he's referring to those early photos of the annual ryegrass versus the mare's tail. And that was maybe some earlier experiments of yours.
Yeah. So, so I think those pictures, so the one picture, our typical go-to is either to do annual ryegrass alone, and we might do that based on what the objective is, right? So if the objective is nitrogen scavenging, then and erosion, you know, preventing erosion, we would think about just going with a monoculture of annual ryegrass. And then when we're trying to add species to that mix, we have had a lot of success of adding forage radish or crimson clover or red clover. And so a couple of those pictures, actually forage radish was in the mix. You're just not seeing it because it was a spring picture and it had winter killed. What we do find is that the rate with forage radish, you have to be careful. You know, if you're above maybe 2 pounds, and there's a lot of nitrogen available at that, you know, it's very responsive to nitrogen. So we've seen forage radish really dominate mixtures when we interseed. And we're always wanting that overwintering from the cover crop. And so if forage radish ends up dominating, then we're not getting all the benefits that we need. So.
Okay, well, thanks, John. We've come to the end of our hour. So thanks everyone for joining us. And again, thanks to John for being here today.